Hello, and welcome to our first episode of nanoCHAT Pub Club, an Ionic Viper video series in which members of the community share about their recent publications. My name is Adam Johnson. I'm at Harvey-Mudd College, and today I'm joined by...
I'm Chip Nataro from Lafayette College on the opposite side of the country.
That's right, the magic of Zoom. We're going to discuss his recent work that was published in Polyhedron entitled Cleavage of the Dimeric Heterometallic Complexes, Palladium, dppf, etc., via addition of monodentate phosphine ligands. And a link to the publication will be found in the description underneath this video. So I'm going to start just by getting into why you wanted to study this, Chip. What were your motivations, or what was the context for studying this series of complexes?
So sure. Hopefully I am now sharing my screen.
I can see it.
Excellent. So a while back, we had developed this methodology to make these bridging chloride palladium dimers. And, you know, it just took addition of a simple, in our case, sodium BArF salt to the monometallic palladium dichloride species to get these dimers to form. And in a lot of catalytic systems, there's plenty of different bases and ions floating around that there's a possibility these dimers can form. So we just wanted to look at what sorts of reaction these dimers would undergo.
I mean, isn't that the hallmark of undergraduate research, is finding a hole in the literature that no one studied?
Pretty much, yeah. And we think we found a nice little niche here.
Yeah. And did you use palladium-free stir bars in your work?
We certainly use new stir bars, yes. Hopefully we're not catalyzing anything we didn't want to catalyze.
Well, I mean, you have palladium added, right? So I guess that's not quite the same thing. You're not trying to claim a palladium-free palladium complex. That would be me. So what were your major results that you found when you did this study?
So we discovered that the dimer does break very nicely whenever we add monodentate phosphines. It's a beautiful reaction in terms of just aesthetically pleasing. The dimer in this particular case is this really deep emerald green color in solution. And when you add monodentate phosphine, pretty much instantaneously, it changes to a red purplish kind of color. So it was a great one for students to like, hey, I think something happened almost immediately. We didn't need NMR to confirm it. But yeah, so we were able to break the dimers and make these monopalladium species. They were cationic with our dppf ligand on it, a chloride, and a bunch of different monodentate phosphines.
Yeah, so when I worked with titanium, when the ligand went onto the metal, it would go from colorless or yellow to sort of a deep red. And so you could always tell when you had a complex. Like I would walk in like, oh, you made a complex. And they would be like, how do you know? Like, and then when I moved to tantalum chemistry, all of that's colorless. And so it was, you did have to, actually pump it down and
do some work and figure it out, right? Yep.
So what are the implications of this work for people either in research or for teaching?
Well, it does give us a feeling about the reactivity of these species a little bit, which I think was nice. And I've also heard rumor that our products are kind of inspiring. They give really beautiful P31 NMR spectra when we make the broken dimers, as we affectionately occur them, because we've got 3 different phosphorus atoms that are all inequivalent. So we wind up with this lovely pattern of doublets.
Funny you should mention that. If you stop sharing your screen, I'll share my screen.
Ooh.
Because I actually asked that question as a homework question in the spring. So hopefully you can see that. So there's a homework question that I asked my students. And interestingly, I mean, this illustrates the collaborative nature of, me and Chip, but the community as a whole, right? I was Sadie's external evaluator for her thesis. So I actually saw this data in December, an earlier version of the data that wasn't quite as clean. And I was so excited because I love to do coupling trees for my my inorganic NMR unit. And so I actually asked this question, unfortunately, I did not save any of the data. Like, there's nothing. I have no information on how the students did on this problem. So I will have to, I'm going to put this up on the site on Viper, just because I think it's a great example of an NMR coupling tree, and I have an answer. And the students did pretty well on it, but I don't have any data because that's just, the semester before you go on sabbatical, right?
Yep, understood.
So where are you taking this work in the future?
So I had students working on it this past summer. What we're doing is we're kind of expanding the number of different monodentate phosphines we're looking at. We also looked at other ferrocenylphosphines, mostly all the work, in this paper, all the work was with dppf, but we've put other R groups on the phosphorus there. And we've made the major leap down to platinum to do some work there. We're also hoping to be able to pull the chlorides off of these monometallic species, because we've used another route to get to similar compounds where there's an iron palladium interaction. So we're hoping if we can pull the chlorides off, we can find a new route to those sorts of compounds. So plenty more work to be done in our little niche.
No nickel?
We have tried nickel. Nickel is the devil. It does things.
I thought water was the devil.
Yeah, well, they're both the devil because they both like each other very much.
Nickel aqua complexes.
Yes. Things have happened. We've got some interesting nickel crystal structures that I just don't know how to tell a story with.
And since we talked about Sadie already, where is she now?
So Sadie started up at Yale. She's a first-year graduate student there, trying to determine what group she's going to work in. I'm actually going to get to see her here in a couple weeks when I go up for my brother-in-law's wedding, so that's exciting.
Cool.
The other students that were on this were Nick Colicchio. He went on to Rochester. And then kind of my favoriteest part of this paper is my daughter is a co-author on it also. She's not a chemist, but she just got her degree in statistics from Baylor, and she did some statistical analysis for us and made us pretty pictures and all that kind of good stuff. So.
Yeah, and I guess I should, full disclaimer, Chip and I are co-authors on a paper where my child did the table of contents figure, right? Nothing like nepotism, right?
Yeah, nothing like it. We're certainly doing our best.
Well, Chip, thank you so much for spending your morning with me. Well, it's my morning. And thank you to everyone who's going to watch this video on our YouTube channel, and join us for our next episode coming up soon. And feel free to contact Ionic Leadership Council if you'd like to be a guest on a future installment of nanoCHAT Pub Club.
Thank you, Adam. Nice shirt.
Nice shirt.